In the next 30 minutes or so, I'm going to show you a new way of thinking about cloud software. And I think the programming languages that we speak and the way that we think about problems, because they determine our ability to express ourselves and therefore to solve problems. So I want to show you something that I've been working on. And I think that when you learn a new way to think, it opens up your mind to seeing problems in a different light. The project is called Teal, and the focus right now is on building data pipelines powered with Python, of course, and running on serverless technology. And if you haven't come across serverless, it's this cool idea that we can build cloud applications without having to manage the infrastructure on which they run. And that's a fantastic thing. But the problem is that we still have to think about that infrastructure. We still have to design our applications with the infrastructure in mind. And we spend a long time up front building complicated architectures for doing things with serverless. We've sort of traded this operational power, like we get this amazing scalability, but we've traded that for development complexity and upfront costs in development time. We spend weeks building something that I think should really take minutes or hours to build, because fundamentally a lot of these problems are quite simple at the heart. And the best analogy that I've got is to think about compilers and assembly code. And in the early days of computing, we would write software in assembly code, but no one does that anymore. These days, we use compilers to generate the code for us, or we write in higher level languages that allow us to express things really concisely. And we can do something in one line that previously would have taken pages of assembly code. And I think that's fantastic, and that's why software is eating the world, as some people say. So when I'm talking about serverless, I'm really referring to functions as a service, and they're also known as cloud functions. There are several. Most cloud platforms support functions as a service, and they're great because you can take your code and you can go and deploy it on the cloud, and that's really quick, really easy. And you can attach your code to events that happen in the cloud, and you can say, when those events happen, run my code. And if the events don't happen, your code never runs and you never pay, and it's lovely, it's wonderful. It's like the nirvana of scalability. You get this fully managed scaling service that goes from 0 to global scale without you having to do anything. So serverless is great, and I think we're going to see massive adoption in the next 5 years. And I think it'll become the right way, the standard way of building cloud applications. But the problem is that when you start putting logic all over the place, you end up with architectures that are hard to understand as a whole. You can understand the individual pieces and you can understand individual lambda functions, but it's hard to understand how they interact, and it's hard to test it, and it's hard to abstract it. So in the way that with software we can abstract concepts and routines and procedures, we can hide the details. You can't really do that with a flowchart, right? A flowchart isn't software. You can't compose them in the way that you can with software. So the goal that I have really is to say, well, how can we make serverless feel like software again? How can we make developing a serverless application feel like developing a traditional pure software application, where we can understand everything and it's all clear in code rather than diagrams, which is a pity, because like these diagrams make us feel good as engineers. Like, they're complicated and they're exciting, and they've got colors, and you can look at them and say, well, I built this super cool thing. Isn't it awesome? But it's not software. So we'll look at an example, and we'll look at how we might implement it with the traditional method, and then we'll look at how we would implement it with Teal, and how Teal lets us think about it differently. The spec's pretty simple. There's nothing particularly interesting happening, really. We've got 3 functions, and they take one parameter, and the parameter is just passed from one function to the next. And this is quite representative of many tasks, right? You've got a sequence of steps that you need to perform, and there's some data that needs to go from one step to the next step. It's not particularly interesting. It's a very, very, very common approach use case. And the constraint is that each function takes several minutes, and we have to use lambda because reasons like serverless, great. But the several minutes constraint means that each function needs to run in its own lambda because lambda has a 5-minute time limit. So, right, okay, well, what do we do? The naive initial approach, which would kind of work, we're simply just passing the value from one function to the next. It's not particularly interesting, but it would work. And we would test it, and we would write unit tests for our functions, and that would be great. And maybe we could build an integration test, and we would use something like local stack to simulate the AWS environments on our local machine. And then we would have a staging account in our AWS account so that we can test the complete thing in a realistic environment. And that's great. That's all good stuff. But we would start discovering that Lambda's not perfect and there are edge cases. So the common way of building this sort of thing now is to put queues between each Lambda function, an input queue and essentially a failure queue. So when things go wrong, we can understand the state of the system. And this is a pretty good way of building this kind of pipeline. It works quite well, but there's a whole lot of manual effort because you have to do everything yourself. And there's tooling that'll help with this, like infrastructure as code, which is great. But really, you're going to take a lot of time, and there's going to be a whole lot of infrastructure as code. Each of these modules, there's going to be a whole lot of work to do. And testing is going to be non-trivial because, again, you're going to have to simulate some kind of cloud environment or just deploy everything to the cloud. Now, what I want from Teal, why Teal kind of started is, well, I want to use Python. That's a given because all my stuff is written in Python already. I just want to take my scripts and run them. I want to be able to test all of my logic locally. I don't want to have to deploy to the cloud to test the logic. And the part of that is that I don't want my logic to be in my infrastructure. So if my infrastructure determines how my program functions, I think that's an anti-pattern. I want contextual debugging, which means if I've got these three functions and one of them fails, I want to know the full context of that failure because the value that failed this function would have come from an initial function. So I want that context. I want operational support, so I want to know, this is kind of a given. I want to know the state of my system, the state of the health, how it's running, all that kind of stuff. That's a given. This last one's interesting. I would quite like to be able to take my application and run it on any cloud, in the same way that I can write Python and run it on any computer. There's an interface or operating system. There's an interface that allows that code to be run anywhere. So let's go ahead and try some Teal and see how we can implement that application. And I'm going to have to, can I end this? Right. Yes. Happy. So Teal. I said Teal was a programming language, and initially it was embedded in Python, but it's not anymore, and I'll explain why later. But there are semicolons. I'm sorry for that, and I hope I get to come back to PyCon. Let's do the classic thing and say hello. You are all awesome. And just show you what I've got in this directory. So I'm just going to run this service file here. And we get what we expect. And it's printed twice because Teal prints the return value. That's not a particularly interesting detail. Let's go and implement our pipeline. We've got our Python code here, which does some very, very basic maths, and I haven't even bothered to check the maths. So That's not important. But we've got our three functions. And to call them from Teal, we need to tell the way they live, which is source.main. And we also need to tell it how many arguments they take. And if you've come across foreign function interfaces, that's what we're doing here. We're telling Teal where they are and how to call them. And then we'll define our computation pipeline, compute, which takes one parameter and simply calls each of those functions. And we'll create a main function to test it. We'll just pass in some random number like 1. It'll be fine. And if I haven't mistyped something. Okay, great. We've got a number, 3. Yeah, that's probably fine. And we can see the Python output coming through here. We can go ahead and deploy this straight away to AWS. And I'll do it with the verbose flag on just this first time to show you sort of what's happening. Essentially, it's going away and creating or updating some infrastructure in my AWS account. And most of that infrastructure never changes. And that's quite an important thing. So there's this layer of hard infrastructure that doesn't change. And then Teal is like this soft infrastructure that sits above it. So that just takes a few seconds. And then we can invoke it. And that just calls main in AWS. And it'll print out some standard output. Now, our original task was to run this in 3 separate Lambda functions, which we're not doing yet. This thread column shows that they're all running in the same Lambda instance or invocation. So let's make them run in separate Lambdas. And the way that we do that is we call them asynchronously, like that. And if you're new to async, it really just says, go and run this function in a separate thread and give me a handle to the result of that computation. And that then we can wait for that function to finish computing. And we'll do that with the other 2. G, and this is H. And then the only difference here is that we're now calling our async version, and we're waiting for the result to come through. And so this is our pipeline. And if we deploy that again and invoke it, and this should only take a few seconds to deploy, even though we've quite dramatically changed our infrastructure, imaginary infrastructure. Now, what we should see is that each of those asyncs has resulted in a separate thread to go and do that particular function computation, starting from thread 0. And there we go. So we've got our output in 3 different threads. And we can add a little bit more information here to give us done. And deploy that. The thing that I want to point out here, as we'll see in a few seconds, is that while H, G, and F are running, the thread that started them, this thread, is completely stopped. So it's not like it's polling. And you can't quite see from this display, so you're going to have to take my word on it, that thread 0 is completely stopped at this point. Once it calls async, once it calls await, it completely stops if that value isn't ready yet. Which means that you're not wasting time, you're not wasting compute time, and you're not spending money for a Lambda function doing nothing. There's no polling and there's no event loop. It's all handled by the Teal runtime. So okay, cool. What if we wanted to do something more interesting, like compute, I don't know, several at the same time, all in parallel? Well, okay, what would that look like? Let me, I'm just going to copy that out because that'll save us a bit of time. And reload that. What are we doing? Well, we've got our 2 compute lines. We're computing this value A and this value B, both in parallel. That's what this async thing does. And then we're waiting for both of those values to be finished, to be ready. And then we're doing something with that result. And there's some kind of branching. Let's deploy that and see what happens. And while that's going, let me point out that like implementing this with queues and lambdas and doing this manually with infrastructure would be non-trivial, because you'd have to synchronize here. You'd have to have some kind of branching logic. You know, you'd have to have two different queues that sort of handle this branching thing. You'd have quite a big diagram, which would be great for you, but quite hard to do. We've just done it in a few lines of code. And that took 10 seconds, which is about right, because the single pipeline also took 10 seconds. So that kind of shows how it's computing them in parallel. And we've got twice as many threads, which again is what we would expect, because it's all happening in parallel at the same time in separate Lambda invocations. So this is great, this is powerful, but be aware, like you could quite easily spin up hundreds of Lambda functions. So that's the caveat that we'll come back to. We'll look at one more example. And this is another fairly common use case for serverless stuff. So you've got your web front end, and you want to do some background logic in your backend server. But the problem is that logic takes some time, several minutes, hours, whatever. And you want your front end to respond immediately and tell the user, you know, we're processing. Maybe your user has requested their data dump for GDPR or something. So you've got to go and do this in the background. And the traditional way of doing this would be like RabbitMQ or some kind of task running process. There are ways of doing it. But the point is that you then have to go and manage that infrastructure. Like you would have to go and set up your Celery server or your task runner, whatever it is. And it's not serverless, and it takes a while. In Teal, it's one word, async, which says, okay, when we call this compute endpoint, kick off this function and just return immediately, and return something called a session ID, which allows the client to then query Teal and see how the task is doing. So we'll deploy that. I went and did Teal invoke, which is not a good idea. That's fine. Let's clear that. What I wanted to do was curl. This is a fairly simple curl. We're just saying hello, which is passing the entire Lambda event to a Python function, which is doing something. The more interesting one is compute. And I should point out first that Teal has set up the API endpoint for us, and I've just set that to an environment variable. So when I'm doing this curl command, it's nothing fancy. I'm just curling this API endpoint, and I'm passing in some data. So when we do compute, we get our session ID out, and we can then go and query that session ID and check if it's done. And in this case, it was done because I only slept for 5 seconds. But that's great. Now we can go and carry on with what we were doing in the first place. Let's jump back into the, thanks for ignoring the semicolons. Like I tried really hard to, so I wrote like 5 different parsers trying to get rid of the semicolons, but it turns out it's quite a hard thing to do. Anyway, let's jump back into the presentation. See if I can get my remote back up and running. Okay, cool. Recap, what have we done? Well, we did this pipeline, and it wasn't particularly interesting. It's fairly straightforward, but I think that this is still better than doing it manually, because we instantly get stuff like log aggregation. So there were 3 separate lambdas there. We didn't have to do any work to pull the logs into one place. And normally you'd be you'd be hunting in CloudWatch, or you'd be trying to manually pull these logs together. And we didn't have to do any work for that. And similarly, I didn't show you, but if one of those functions broke, we would get a nice stack trace that works across threads. So that's great. We did a little bit of parallel stuff and branching, which is really cool because it took a few lines and you can see what the code is doing. You can test it locally. I don't think I did test this one locally just because deploying it is so easy. But you could have tested it locally, make sure it all works, and then deploy it. I didn't show you mapping, but essentially, this is like a for loop, right? You've got a list of values, and you want to apply your function to every value in that list. And Teal functions are first class, just like Python. So you can pass the functions around, and you can do functional style programming with them. So that's great. You can go and compute your thing in parallel, and then wait for the results to come back. We talked briefly about this API endpoint, which is really the thing that I love about this is the workflow is really, really simple and straightforward. And it's quite slow for now, like several seconds to respond. But that's an engineering problem, and that's just about optimizing Teal's upfront load time. So that'll improve. But the workflow of just saying, hey, go and do this thing in the background is just great. And I've been using it in another project and just loving it. So easy. Some things I didn't show you. A lot of this is kind of what you would expect, and it's really about making the programmer life easy. Like if I want to upload a file to an S3 bucket, which is an object store in AWS, and I want my code to run whenever a file is uploaded, that event happens. I just want to modify one line in my source file that says trigger this function. And at the moment, it's a much more complicated process where you're going and configuring a whole lot of stuff. And it's not particularly fun, and it's not particularly intuitive, and it doesn't feel that nice. Maybe I'm super biased in that. We'll see. The other things, sort of what you would expect. You need to be able to customize the permissions that your function has, and the build scripts, and all the memory, and all the things you'd expect in Lambda. Now, the question that I want to address, and it's really important. Lots of people ask me this, and I ask myself this, and it's why is Teal not a library in Python? Why is it a separate thing? And well, the answer is that it was originally a library. That's how the project started, and it was just really limited because, well, the problem really comes when you've got a function like this, where you're doing some computation, and halfway through the function, you want to stop. And I couldn't figure out how to do that in Python without completely obscuring the Python entirely, which would defeat the point. But if you've got a Python function and you want to stop halfway through, how on earth do you serialize the entire state of the interpreter or sub-interpreter and put that in the disk, and then at a later point pick it up again? I couldn't figure out how to do that. It seemed like way too much of a task. But if you've got some ideas, that would be awesome. It would be really, really cool to see this 100% native in Python. The logic here, this halting logic that I was just talking about, really says, I'm thread 0, and I want to use this value A. Now, is it ready? If it's ready, I can carry on running right now. If it's not ready, I'm going to wait for it. And I'm going to tell the thread that's running, computing A, when you're done, restart me. And then I'm just going to stop entirely. And when that thread does finish, it'll say, okay, who's waiting for my results? And then it'll go and pass that results to those functions, those threads, and carry them on. So it's a bit like an implicit callback, except that you don't have to do that logic. And there's no event loop, there's no polling, there's no third-party service that's like coordinating all these things. It all happens at runtime, managed by Teal. Now, we're going to do a really, really quick overview of what Teal looks like under the hood. This is probably like multiple talks, so I'm not going to go into any detail, but please come and talk to me afterwards if you want to know more. it really is a virtual machine that's implemented in Python and can call into Python directly. And it's a virtual machine in the sense that there are instructions and there's a data stack and a call stack and a standard output model and some kind of CPU, some idea of a CPU that's evaluating instructions. And that's all very standard VM. That's nothing particularly interesting or innovative. The cool difference is that there's this layer of persistent storage, and you can have multiple threads. And Teal abstracts the notion of a thread and memory, which means that you can run anywhere that has memory and some notion of computation. So in AWS, a thread runs on lambda. On my local machine, a thread just runs in a thread. There's nothing interesting there. And in AWS, the memory is DynamoDB, but locally the memory is just my computer's memory. When it's deployed to AWS, it looks something like this. The Teal VM is in that runtime box over there. And that's the kind of interesting thing that communicates with the rest of your account. And there are two other APIs that are worth mentioning. One is the control API, which does what you sort of expect. It lets you communicate with your Teal instance and get logs, figure out what's going on, program the code, list the sessions, all that kind of stuff. That's what the CLI interacts with. And the other one is the trigger API, which is a fairly flexible, generic, well, you can extend it, interface that lets you trigger Teal functions. And I've implemented 3 triggers, but you could go and attach anything that can call lambda, can call Teal. So you can go and modify that and add your own triggers or third-party services. And worth mentioning, there are a bunch of really awesome libraries that made this possible. It wouldn't, save years of development time. These things are great. Definitely go and check them out. The compiler, this is going to be also a super high-level overview. The Teal compiler is nothing particularly innovative as compilers go. Doing it in Python has been a whole lot of fun and quite an interesting experience. But really the goal is to go from Teal text to an executable that can run on the VM that we've just talked about. And it comprises of a few things there. But the interesting thing is this middle optimized step where the compiler kind of has the power to analyze our code, analyze our function or our program, and then modify the executable and potentially modify the infrastructure. So if we say that our function needs to be, respond within 20 milliseconds, needs to be in these regions, and it needs to respond to 1 million events at the same time. Well, the compiler can then go, okay, well, it needs to be attached to a Kinesis instance. And the compiler can just go and then sort that out for us. And that's not done yet, but that's the kind of thing I think could be done and would be really, really cool. Again, a bunch of really awesome libraries that made this possible. So many parser libraries in Python. It's fantastic. Okay, so our checklist. Well, we've got the top 3 things, which is great. And the bottom 2 things are on the way. So those I can see something, I could see this being far more powerful than it is now, particularly around operational support, because at the moment there's just a CLI. And what we really need is a dashboard where we can see the entire state of our system, manage deployments, do stuff like one-click rollbacks, blue-green deployments of entire serverless applications, all the kind of like really, really high-level operational support stuff that is quite hard to do now. Some of the limitations, very briefly, the bandwidth, I think, will always be limited physically by, if you've got your CPU and you've got your memory, I think we'll always be limited by the data bandwidth between those 2 things. There's a physical connection there. There's a network that we have to transfer stuff over. So I think we're always going to be limited in bandwidth speed there. Lambda startup time and concurrency limits and costs, those I think are not, those will improve. As as Lambda becomes more competitive, as more players enter the cloud functions game, things like startup time, those will just go down. Things like cost, that's just going to go down because it's becoming more competitive. It's still worth being aware, though. You want to be careful. Like the new denial of service is denial of wallet. You've got to be careful about how many of these things that you spin up. But I think Teal can probably help with that in the compile stage. Well, so that's Teal. As you can probably tell, I'm quite excited to see how we can like go beyond infrastructure, and quite excited to see how the cloud is going to change in the next few years. If you'd like to contribute or support this work, like, great, reach out to me. It'd be cool to chat. I want to also say thank you to the organizers. It's incredible. This year is just completely crazy, and you guys have done such a cool job getting this out there. I was talking to Marlene earlier, and the 5 days of conference, like, that's hard. That's incredibly hard, and you pulled it off. So well done. It's wonderful to be here and to see all the cool things that you guys are working on. From Daniel, a question in case you encounter later. When would you choose to use a serverless solution, and when would you say Docker containerization looks more suitable for a particular use case? Yeah, this is a great question. So the answer is, if you're worried about traffic changing, if the demand for your service is slightly irregular, then go for serverless. If you've got a very regular demand for your service, like you can predict, you're going to have a constant 100 requests a minute all the time, no matter what, then Dockerization is great, and you can use Kubernetes to get some more scalability. But the serverless platforms really start paying for themselves when you've got the servers that might go up and down. It fluctuates. You don't know how big it's going to need to scale, especially for new projects. I would totally recommend it for new projects because you just get all the scalability out of the box, and you have no idea how big it's going to go, and you can start for free. The AWS free tier is just massive. But then again, if you prefer in particular like web frameworks, they tend to work far better with Docker, with containerized solutions, because you can just put them all in one box. Does that it's a big topic. Yes, so I guess Teal is pretty heavily tied to AWS right now. What's your take on doing something similar for GCP, separate, inspired by Teal? I think, yeah, so the Teal backend is intended to be, hey Rob. The Teal backend is really intended to be completely abstracted. So yes, the idea is that someone could go and write a Teal backend for Kubernetes, for example, passing data between Kubernetes nodes. That's not really a particularly easy way of doing that right now. So yes, Teal absolutely could be implemented on GCP, and that's in the plans, that's in the pipeline. And if you want to come and help with that, like, that would be great. It would be a big PR. Is there a beginner-friendly book or article you'd recommend someone new to serverless? I think there's a. Let me post. Well, I don't have the link right now. There's a chap called Nader Dabit who wrote a book called Full Stack Serverless, and I would recommend going checking that out. It's pretty good. His specialty is using AWS. There are lots of very, very good articles though on the web. There's all kinds of good stuff. How much time would you say you've saved using Teal? Are we counting the 5 or 6 months to develop Teal? If we don't count that, well, Teal kind of started because last year I was working on some stuff, and I don't know, it took like a few weeks to set up one of these pipelines from scratch, and it felt like a massive chore, and it felt really awkward. So that was a few weeks. I could do the same thing now in like an hour. So I think it's that order of magnitude. days to hours. Now, if you're starting from a place where you've already got your own framework set up and you've already built your own way of doing things, that difference will be less. But especially if you're starting from scratch, you're going to save tons of time, because you don't have to learn about AWS. You don't have to implement a ton of infrastructure as code. Yeah. Weeks to days to hours. Have I missed some questions? This is so strange. I feel like I'm talking to myself and I'm just scrolling through a chat. Have I missed questions? Why did I decide to start developing Teal? Yeah, great question. And that sort of ties into the previous point. I think there are these trends in technology where, and you can see this in several industries, where we start with like really specific hardware, and as we build more stuff on that hardware, we start developing software to make it easier. You can see this with computers, right? Like I said, we used to build specific hardware for specific problems, and then we move towards general purpose CPUs, and now we just write software. And we saw this with graphics cards as well. We used to have very, very specific graphics cards for specific tasks, and now we have GPUs with a software layer that sits on top. So when you see that kind of trend, and as a software engineer, general purpose is always better, right? And I guess one of the reasons fundamentally is that I want to get stuff done faster, and I don't want to do the boring stuff. I don't want to be building repeated scaffolding for every project. So there's a couple of those things, I suppose, that went into it. And like I said earlier, I was working on a project that had immediate relevance with the project. Daniel, yeah, I think, where am I going next? So at the moment, it's like version 0.4 or something. It's not complete in a couple of senses. And it's certainly not production ready in the sense that it needs a lot more testing. I think we can push the boundaries a lot more. And one of the big things is infrastructure. So where am I going next in the immediate future? Teal needs a couple more things. Things like it needs an import system so that we can start sharing code. It needs proper error handling in a nice programmatic way, like think exceptions, that sort of thing. But cross lambda, that's kind of unheard of right now. So there are a couple of immediate features that I want with Teal. So those are like the immediate focus, and then it'll be about getting to a version 1.0 release. And to do that, it just needs to be tested in lots of different use cases, and it needs to get exposed to lots of different things. And yes, it's open source. Thank you, Marlene. So that's the GitHub repo. It needs a ton of work that I'm around contributing. I'm quite new to open source, and I've never maintained an open source project before. So if you guys can help with that, I'd love it. It's named Teal is named after a color. I wanted a color that was like vaguely similar to the sky, and I quite like blue and green. So mix them both and you get teal.